Alright, now for tutorial question 3b, okay, we actually have an inequality that is as follows: 6 over the absolute value of x plus 1 is really smaller than absolute value of x. Alright, so one easy way to quickly solve this is to note that this expression is entirely in terms of the modulus of x. Okay, so what we can do is actually use substitution. Okay, so what I will do now is to let y to be equal to modulus of x. Okay, this will simplify our inequality very quickly to one that is only involving an algebraic fraction. Okay, so now what I do is I bring everything to the left hand side of the inequality to make the right hand side 0. So I will get 6 over y plus 1, subtract y is really smaller than 0. So this will give me 6 minus y times y plus 1. Okay, so what I have now is 6 minus y squared minus y. Okay, so you note that on the top of the fraction, or rather in the numerator of the fraction, okay, it's actually a quadratic expression. Okay, so to make things slightly simpler, let me just multiply both sides by -1 so that I can factorize the expression more easily. Okay, but in doing this, remember that you need to change or reverse the inequality sign. Okay. So what I now should get is y subtract 3 plus 3 times y minus 2 divided by y plus 1 is greater than 0. Okay, so to carry on from here, remember that we need to check where is undefined, or rather where the algebraic fraction is undefined. In this case, y cannot be -1. Okay, so following which, multiply both sides by a suitable positive expression. In this case, I will multiply both sides by the square of y plus 1. Okay. So what I now get is a fully factorized polynomial expression. Okay, so by drawing the number line, okay, and taking an arbitrary value of x as usual, a good choice would be 0. Okay, and then sketching the graph accordingly. So at 0, I should get a negative value for the polynomial expression. Okay, and each of the factors is linear. Alright, so it will cut the graph, it will cut the x-axis at each of the roots naturally. Alright, so now let us choose the points to exclude. In this case, y cannot be -1, so let me label it with an empty circle accordingly, and the rest of the roots have to be excluded as well, because this is a strict inequality. So therefore the final answer you should get is -3 is strictly smaller than x is strictly smaller than -1, or x is greater than 2. Alright, sorry, so the variable now at hand is y, not x. Okay, so take note of that. Okay, so now once we have this, alright, we'll need to replace the original the new variable y back by the original variable. So negative 3 is smaller than modulus x is smaller than negative 1, or modulus x is greater than 2. Okay, so if you refer to your lecture notes for the second inequality, this is equivalent to x is smaller than 2 or x is bigger than negative 2. Alright, now for the first inequality, this is where a lot of students make the mistake, okay, of trying to open up the modulus. In the first place, okay, do remember that the modulus of x is always non-negative. So if you are faced with an inequality as such, where you see a modulus of x is between two negative values, immediately you should be able to tell that there is no solution for this inequality, because it is not possible for your modulus of x to be negative. Alright, so please do not try to open up the modulus and try to find a solution in this case. Okay, so what we have now is no solution in bracket, or x is less than 2 or x is greater than negative 2. Okay, so the first inequality in bracket, or rather the first solution, or rather no solution in bracket, or the second answer in bracket. So the answer would be x is less than 2 or x is greater than negative 2. Okay, this will be your final answer. Okay, remember that if it's no solution or another solution, okay, taking union, it will be just the other solution. Okay, because no solution simply refers to the empty set. Okay, in other words, the set of without any elements. Okay, so that set union with any other set, okay, would be the other set.